Hello, greetings. It is I, Mr. Burkhart, making an answer key for you of the wrong piece of paper. So that's cool. I'm going to go and start with A. There we go. Also, I've got my timer running so that I don't take too much time on these videos. I'm trying to get them to be between 6 and 10 minutes, and then I'll stop and make a new one. So, Carlos and Dominique collect the following data from an experiment where they exerted the same force, F, to identical sized boxes with different masses and recorded the acceleration. I have this stinking suspicion I'm going to need a ruler. Plot the acceleration of the boxes versus the mass of each box. Sure, we can watch the teacher do that. Looks like this is all provided for us, so that's kind of sweet. So at 2, I'm at 1.5. 1.1, 2, 3, 4, so 2 is here. There we go. I already know the secret. I'm kind of cool. 4 is at 0.75. Well, that's right here. 5 is at 0.6, which is here. And I'm not going to need a ruler. I misspoke. That was silly of me. I should know better. That's 0.4. Ruler's not going to help me with this graph. 12, we're at 0.3, which is here. 15, we're at 0.2, which is here. And at 18 is here, which is 0.15. Boop, 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 boop. Plot the acceleration of the boxes versus the mass of each box. Done! Boom! Bob's your uncle. Scutta hey, scutta ho. Huh. All right. As based on the graph you created in Part A, identify the correct relationship between the acceleration and mass of an object. Fill in the blanks. So here's mine, right? You know, one thing that's you should always do when you make a graph is you should always like draw a best fit line. So there's my best fit line. It's a curve. So here is the one that matches it, right? As x increases, y decreases. As mass increases, acceleration decreases. Therefore, acceleration is inversely. I'm just copying the words here. Proportional to mass. Based on your analysis of RB, what could be graphed instead of mass and acceleration that would lead to a linear relationship? Well, I could graph force and acceleration. What's the physical meaning of the slope of the linearized graph suggested in Part C? It would be mass. Right? If I graphed force versus acceleration, and the slope of the line, this would be y equals mx, right? The slope would be the mass. All right, that was A. That was 3 minutes. Let's go to B. I'll probably have to flop and twitch around looking for the right papers here because I think I created a giant mess. Maybe B is just... Oh no, it's just this one piece of paper. All right. Analyze data. Use the data provided by the motion detector to find a pattern between the change in Angela's motion and the interaction with Blake. Fill in the blanks. Okay, Angela is standing on a very low friction skateboard while Blake pushes her away from the motion detector, which is set to record velocity as a function of time. In trial 1, Blake pushes softly. In trial 2, Mama Bear. In trial 3, Daddy Bear. All right. Use the data provided by the motion detector to find a pattern between the change in Angela's motion and the interaction with Blake. Fill in the blanks. When Blake pushes harder, the slope of the velocity versus timeline increases, gets steeper. Since slope what? Since slope increases, the acceleration is increasing, getting bigger. When Blake stops pushing, the slope of the velocity versus timeline becomes flat. Since the slope is now flat, the slope is now 0, the acceleration is 0. All right, good job. The students then repeat the experiment, this time with, see, the slope of this line is acceleration. It's getting steeper. The students then repeat the experiment, this time with Angela holding 2 textbooks and then 4 textbooks. So sketch a diagram of the velocity versus time for Angela with 2 and then 4 textbooks. Blake pushes with the same force every time. The velocity of Angela without textbooks is already sketched. All right, so force equals mass times acceleration, or acceleration equals force over mass. So what we're going to do is we're going to keep the force the same, and we're going to increase the books, right? So that means the acceleration is going to get smaller. So for sketching, when we have 2 books, the acceleration is going to be less, maybe something like this, 2 books, and maybe something like this, 4 book. Because see, it's going to have a slower slope as the mass goes up. And we're just looking for patterns and shapes, not exact numerical answers here. The following statement is written to describe what will happen after the first 5 seconds when Blake is no longer pushing. Cross out any incorrect statements and explain why they are incorrect. Use the checklist to help you check your own writing. After you've written your answer, make sure that you can check off the statements in the list or revise your answer. After Blake stops pushing, Angela will travel at a constant speed for a few seconds before she runs out of force. For a few seconds, then she will decelerate and stop. Checklist. I answered the question directly. Okay, cross out. Why they're incorrect. Wow. Angela will travel at a constant speed for a few seconds. Depends on the friction. It could be a lot more than a few seconds. And before she runs out of force. We don't run out of force. Force doesn't work like that. You don't run out of it. What will happen is, first law, she will continue moving unless acted on by an outside force. There's the law. I use force. The net force is 0 once the pushing stops, and so then the acceleration is 0 until friction slows her down. I don't know. There's a lot of things you could say here, right? There's not one right answer. Oh, we're at 8 minutes. So we're going to call that video good. And we're going to call that one 2A and 2B. Oops, I did not want to do that. I want to stop the video. Okay, done. That's what I need to click.